Very good morning, class. In yesterday's video, I have discussed some rule of image formation. There were three principal ways by which we can form image of any object which is placed anywhere in front of concave or convex lenses. So today we will discuss the different condition in which objects are placed at different places with respect to the convex and concave lenses. Before we start, let's quickly revise the yesterday's video in which we have studied some rule of image formation. There were three rules. The first rule is when ray passes through the optical center, it does not deviate. The second rule was when the ray is coming parallel, then after refraction will pass through the focus. And the third rule was when the ray is coming from the focus, it will become parallel after refraction. So we will use these three rules to find out the image formation by the convex and concave lenses. As you can see on the board, we have the topic is characteristics and location of images for a convex lens. When we say characteristics, we deal with 3 points. First, is it real or virtual? Right. Second, is it inverted or erect? And third, it is diminished or enlarged. So these 3 points consider in the case of characteristics, and obviously location where the image is being formed with respect to the convex or concave lens. Alright, so let us start with convex lens. What are the cases in convex lens and what are their characteristics and the location of the object and their images. So let's start with the first case. Alright, the first case is when object is placed at infinity. That means u is infinity. What is u? I will tell you later. Here the object placed at infinity. Always remember, when the object is placed at infinity, then the rays coming through the object is always parallel to the principal axis. Right? So that is convex lens, optical center O. This is the primary focus f1, and this will be the secondary focus f2. Here we can take one more distance, twice of f1. Here it will be twice of f2. Alright, now when object plays at infinity, u is infinity, and I told you when the object at infinity, rays are always parallel to the principal axis. So ray will come like this. Alright, where will pass? It will pass from focus, it will pass to the focus. As I told you, we need at least 2 rays to find out the object to image. So one more I am taking the same. So if you see here, it is intersecting at the focus, right? So location, I'm writing here a table, right? Where's my duster? Here it is. I'm writing here a table. First, location, and second for characteristics. So what is the location? Locator is at focus. So image will be formed at focus. Now what will be the characteristics? Because the rays are actually intersecting, that means image must be real, right? And real image is always inverted, always remember. Real image can never be erect. And third, you can see here the size is point sized. It is highly diminished, or we can say point sized. So these are the location and the characteristics in this case. One more thing we can do, that when the object is not infinity, but we can say this is first A part and first B part. When object is very very far away with respect to its focal length, and when this happened, what does it mean? When the object is far away from its focus, I mean, let's suppose the focal length is 10 centimeter and object is at, let's say, 100 centimeter, right? It's very very large. Now what can be the difference? The only difference is when the object is not at infinity but it is far away, then light ray coming from the object will be parallel to each other but not parallel to the principal axis. Okay. So light ray is coming parallel to each other like this. First ray is going like this. We know it will pass undivided because you can see here it is passing through the optical center, right? Second, I'm taking that this is going from the focus. So when it comes from the focus, it will become parallel after refraction. So parallel, they again form the image at focus, but now the only difference is image is not point sized. It is diminished but it is not point sized. So in this case the only difference is it is not point sized but it is highly diminished. Right? So location at the focus, it will be real, inverted and highly diminished. So I'm telling you again what the difference. In the first case object is at infinity, and here object is not at infinity but it is far away from the lens. Let's discuss the second case. When object is placed beyond 2f, that means now u is greater than 2f. What does it mean? Okay, this is convex lens, this is optical center, this is f1. So take twice the distance here, this will be 2f1, right? So similarly on the other side that will be the focus to f2, and this will be twice of focus 2. Now the object is beyond 2f, so it is placed anywhere here. This is object. Let's make it large. Alright. So this is, let's say this is AB, is object. Now you know that to find the image we use any two rays. So first ray I am taking is parallel, and when the light is parallel, it is always passed to the focus. Right, so this is passing through the focus like this. We need one more ray, so the next ray I am taking from the optical center. Next ray is going from the optical center, let's say where it will intersect. Okay, so it is intersecting somewhere between the F2 and 2F2, right? So this is the second case. So what is the location? Location is between F2 and 2F2. Okay, is it real? Yes, because it is made by the actual intersection. It is inverted. Yes, it is again inverted. And you can see here, this is smaller than the object, so it is diminished. Right? So that's your second case. Now let's see the another one in which the object is placed at 2F1. Okay, so I'm writing here the third case. It is when object at 2F1, that means U is equals to 2F1. So let's make the diagram. Convex lens, optical center, this is F1. So the same distance here, it is 2F1. Okay, it will be F2 and will be 2F2. So here we have an object AB at 2F1, right? First ray parallel to the principal axis pass to the focus. Second ray from optical center. You can see here it is intersecting at exactly 2F2. So when the object is placed at 2F1, image will be formed at 2F2. So location is at 2F2, and the image characteristics is real, yes, inverted, yes, but it's not diminished. It is of same size. Same size, right? So this is your third case. Let's discuss the fourth case. Now here, when object is placed between 2F1 and F1, right? So let's see here. This is convex lens, optical center O. This is F1, so at same distance it will be 2F1. Here it will be F2, and here it will be twice of F2. So object is placed somewhere between F1 and 2F1. So let's say this is the object, right? This is AB is the object. Again, same rule. Parallel ray will pass through the focus. Alright. Second, it will from the optical center. So you can see here these two rays are intersecting away from the 2F2. So this is A dash and B dash. Now it's clear from this diagram that image location is beyond 2F. It is beyond 2F2. Characteristics, yes, it is real. It is inverted, and you can see this is object and this is image. So the image has been magnified. So this is enlarged. It means it is the size of image is magnified, it is bigger than the object. Fifth case, when the object at focus, when the object at focus, that means u is equals to focal length f. Let's make the diagram. So this is f1, this is twice of f1, this is f2, and this is twice of f2. Object is here. This is the object AB. Now use two rays, first parallel, principal axis, pass through the focus. Second from the optical center. Can you see? These two rays are parallel to each other, and you know that in the mathematics you must have studied that two parallel rays always intersect at infinity, right? We just assume that they will intersect at infinity, so they are going to infinity. That means the location is at infinity. Characteristics: real, inverted, and highly enlarged or highly magnified. Only last case has been it's remaining, which is what if the object is in between the optical center and the focus? What will happen? Let's see. The last case for convex lens is 7th, I think it is, when object is placed between focus and optical center. And we can say this is the most important case in the convex lens because it has a very important application in the optical instruments like telescope and the microscope. Okay, so let's see what is this case. This is our convex lens, optical center O, focus f1, focus 2 f1. Now the object is somewhere here between the optical center and the focus. This is AB, right? So here it is the f2 and 2f2. Again we will use same rays. First, which is parallel, will pass through the focus, right? Second, I'm using the through the optical center. Now as you can see that again these two rays are not intersecting, but they are also not parallel. So what if we retrace them backwards? See, they will intersect somewhere beyond 2f1, and you can see the image is upright, that means erect. In all of the cases, image formed by convex lens was inverted, but in this case it is erect. And second thing, the light ray is actually not intersecting. We have retraced back and then it intersect. So it is virtual image. So this is the only case for convex lens when the image is virtual. Second, it is erect. And third, magnified. location beyond 2. Right? So these are the cases of image formation by convex lens. In the next video, we will discuss the image formation by concave lens also. Please revise them and try to make these diagrams with yourself in your textbook. Till then class, thank you so much.